Hello and welcome to Selection with Sathi. Today we explore class metaprogramming from Fluent Python chapter 25. We will learn how to create classes dynamically with type, how _init_subclass hooks into class creation, how class decorators modify classes after they are defined, and how metaclasses control the creation process itself. The type built-in function has a secret superpower. With one argument, it returns the type of an object. But with three arguments, name, basis, and namespace, it creates an entirely new class at runtime. The name is a string, basis is a tuple of parent classes, and namespace is a dictionary that becomes the class body. This is exactly what Python does when it encounters a class statement. It calls type with these three arguments. _init_subclass was introduced in Python 3.6 as a simpler alternative to metaclasses. When you define a subclass, Python calls _init_subclass on the parent class, passing the new subclass as the first argument. You also receive any keyword arguments from the class statement. This hook is perfect for three things: validating that subclass have required attributes, automatically registering subclass in a registry, and injecting methods or behavior into subclass. Always call supers _init_subclass to support cooperative inheritance. Class decorators work exactly like function decorators, but on classes. Writing at decorator above a class definition is equivalent to MyClass equals decorator of MyClass. The decorator receives the class object after the class body has fully executed. It can add methods, modify existing attributes, register the class, or even return a completely different class. Class decorators are simpler than metaclasses, easier to understand, and can be stacked multiple decorators applied to the same class. A metaclass is a class whose instances are themselves classes. The default metaclass for all classes is type. To create a custom metaclass, inherit from type and override _new. _new receives four arguments: the metaclass itself, the class name, the tuple of base classes, and the namespace dictionary. You apply it with class MyClass in parentheses metaclass equals meta. Once set, the metaclass is inherited by all subclass. But use metaclasses as a last resort. They add significant complexity. _prepare is a class method on the metaclass that runs before the class body executes. It receives the metaclass, class name, and basis, and returns the namespace mapping that will collect the class body definitions. By default, this is a plain dictionary. But you can return an OrderedDict, a default dict, or a custom mapping that records the order of definitions or adds special behavior. Since Python 3.7, regular dicts preserve insertion order, so _prepare is less commonly needed now. Understanding the order of evaluation during class creation prevents subtle bugs. First, _prepare creates the namespace dictionary. Second, the class body executes, population that namespace. Third, type _new builds the class and calls $set_name on every descriptor in the namespace. Fourth, _init_subclass runs on the parent class. Finally, class decorators apply from innermost to outermost. Knowing this order tells you exactly when each hook has access to what information.
Let's build a record factory using type. The function takes a class name and a list of field names. It creates a double underscore init that assigns positional arguments to the named fields. It creates a double underscore repro for nice printing. Then it calls type with the name, an empty basis tuple, and a namespace containing these methods. Now dog equals record underscore factory of dog, bracket name and weight, and dog of rakes, 30 creates a record with those attributes. Double underscore init underscore subclass can autogenerate a constructor from type hints. The checked base class defines double underscore init underscore subclass. When movie inherits from checked with annotations title string, year int, box underscore of is float, the hook reads those type hints using get underscore type underscore hints. It then generates a double underscore init method that accepts keyword arguments and assigns each field. The generated method is injected onto the subclass. 0 boilerplate, the class just declares its fields and gets a constructor for free. A class decorator can handle both registration and method injection. The register underscore plugin decorator adds the class to a global plugin underscore registry dictionary, using the class name as the key. It also injects a class underscore id class method that returns the class name. Then it returns the class unchanged. Decorate any plugin with that register underscore plugin and it's automatically discoverable, no metaclass required, just a simple callable. When you truly need to control class creation, metaclasses are the answer. Schema meta inherits from type and overrides double underscore new. It reads the double underscore annotations from the namespace, creates the class using supers double underscore new, then builds a underscore schema dictionary mapping field names to their type names. Now class user with metaclass schema meta, annotated with name string and age int, automatically gets user dot underscore schema equals name string, age int. Schema generation at class creation time, fully automatic.
Key tips for class metaprogramming. Try double underscore init underscore subclass first. It handles 90% of what metaclasses do with far less complexity. Class decorators are great for registration and method injection. They are simpler than metaclasses and can be stacked. Only reach for metaclasses when you need double underscore prepare or must control types double underscore new directly. And always remember the evaluation order, class body, then set underscore name, then init underscore subclass, then decorators. For more concept videos like this, download the Selection with Sathi app. Like and subscribe. Thank you.